So this is my little setup to make some table salt, also known as sodium chloride. So just from the name sodium chloride, you can pretty easily see that it has two major components, sodium and chlorine. On their own, both elements, sodium and chlorine, are pretty reactive and dangerous. However, interestingly enough, when they are combined, they form a nice edible salt. This is an interesting demonstration that shows how drastically different the properties of a compound can be compared to its components. So for the first step, I'll cut off a small piece of sodium that I'm going to be using for the reaction. Sodium metal is actually quite shiny, but it quickly reacts with air and moisture and forms a white coating. You can see a bit of the shininess after it's cut on the bigger piece. The liquid that you see dripping off the sodium is mineral oil, which is what the sodium is stored in. This is my chlorine generator. Inside the flask is chlorine pool pellets. I then poured hydrochloric acid into the flask and it reacts to produce chlorine gas. As you can see, the chlorine has a faint greenish yellow color. The top is blocked, so the chlorine is forced down the hose. The hose leads into a larger flask with sand at the bottom. The sand is at the bottom to prevent the glass from cracking from high heat. Inside the flask is then dropped a small pellet of sodium. This is half of the piece that I cut off in the earlier shot. A little water was added to get the reaction started, but I think I added a bit too much. The white cloudiness that you see is a suspension of really small particles of sodium chloride. The white stuff on the walls is also sodium chloride. When a lot of the sodium chloride cloud has dissipated, it's a lot easier to see a lot of the white sodium chloride all around the flask. I decided to try it again, but this time putting much less water to see what would happen. It took a bit longer to get started and there was more flame, but it wasn't too impressive. It was pretty short-lived and it wasn't very spectacular. Maybe it would be better if I used more sodium. The interesting part is that with the second run, since the sodium stayed in one place, I was left with a solid block of sodium chloride at the bottom. Unfortunately, because the sodium was reacted in sand, it's highly contaminated with it. So you can see here that when it's broken up, that a good portion of it is sand. I really did want to get the sodium chloride as pure as possible, so I opted to carry out the experiment again using the second most common method. This involves heating the sodium up until it melts and lowering it into an atmosphere of chlorine. This way, I wouldn't need to use sand and I could probably get a much purer product. Because no sand was required, I opted to do the lazy method, which is putting the chlorine pellets at the bottom of the flask and simply pouring hydrochloric acid in. To lower the sodium in, I made somewhat of a ghetto little contraption which involved a broken test tube and an alligator clip. The sodium was placed at the bottom, and then using a torch, I melted it. I heated the sodium until it ignited, but when I lowered it into the chlorine, it went out, which was quite surprising for me actually. Despite it going out, all of the sodium that was exposed to the chlorine became nice white sodium chloride, but unfortunately this is not the spectacular reaction that I was expecting. I took the sodium back out and I heated it a lot until it was molten red. This time, when I placed it back into the chlorine, it was a much more spectacular reaction. The sodium burned really bright and it turned my Erlenmeyer flask into a lantern. From demonstrations and other resources that I've seen online, I honestly expected this reaction to last no more than a few seconds. I'm not sure if I just used more sodium than the other demonstrations, but the reaction seemed to go very vigorously and bright for at least a minute. Now that the reaction had died down, it's possible to see the reaction going on inside the broken test tube. Compared to the other method where it was ignited using water, this method produced a lot more sodium chloride smoke. The test tube was coated in a thick layer of nice white sodium chloride. I tried to scratch off as much as I could, but it's honestly very hard and stuck very tightly to the glass. When it's poured out, you can see that this product is much cleaner than the last run. This sodium chloride was surprisingly fluffy, maybe because it wasn't contaminated with so much sand. Although this product looked nice, white, and clean, I still highly advise that you don't sprinkle this onto your food.